In the previous video, we wrote this code, so let me explain how it works. All those lines are written using C# syntax. Think about the syntax as a sentence. For others to understand what you wrote, you need to put spaces in between words and add comma to signify the end of your sentence. With C#, we need to follow specific rules so that the computer can understand what we wrote. In our script, we have keywords like public, class, or the way that we define a method, and those are the rules that we need to learn in order to write our own C# code. Back in Visual Studio, look at the top of your script. You will have some lines here starting with the using keyword, but I want you to focus on the semicolon at the end of each of those lines. We have discussed previously that this represents the end of the code line for our C# compiler. In our project, go back to the update method when we have typed our transform line of code, and here if we use enter to create a new line of code and type a semicolon, it will work perfectly fine, although this line of code does not do anything. The point is here that this is completely legal because it adheres to the C# syntax rules. It is also important because if our line is too long and we can't really see it on one screen, we can use enter and move the rest of the line of code to the next line, but if it has a semicolon at the end, the C# compiler will treat those two lines as a single line of code. Well, that's great, but what about the start method? We have the void, we have start, we have some parentheses, but there is no semicolon at the end. And if I add one, this will cause an error. So what's going on here? That is because start is a method and its task is to define lines of code that should be performed together, and the curly brackets below defines what is known as a code block, which is just a fancy way to call a group of lines that goes together. If we go to our update method, we have two lines, this empty one and this transform one, so those are the two lines of code that we want to perform together. And if we go to our start method in between those curly brackets, and we are going to type update, and we are going to add parentheses and a semicolon at the end, basically we are calling this code from the update method. Update is the name of the method and the parentheses are a way to call this method. So all this method call means is that at the runtime, those two lines of code from the update will be pasted where we have called our update method name with the parentheses. And we do not do that because we do not want to duplicate our code. So the method is just a name that we give to a code block so that we can easily reuse that code that we wrote previously by calling the method name instead of copying those lines of code. But why do we want or need to reuse some parts of our code in multiple places? Well, every C# application is built out of objects created based on a class, so a script that someone else wrote. Those classes contains methods and data. Think of an object like a car. The color or fuel level of the car represents its data. Data tells us something about this specific car object. Methods are functionality that the car object can perform, like accelerating or braking. For example, enemy object can have health value and move method that allows it to move. This way, when we have multiple enemies, they all reuse the same movement logic, but when I kill one, only its health value drops down to 0, while others keeps attacking the player. So objects are separate enemies, while enemy class defines what each object should have or be able to do. So how do we define a class in C#? In Visual Studio, if you go to our script, you will find public class keywords and the weapon name, which basically can be read as this is the definition of a weapon object. In Unity, we again have this weapon class but not an object just yet. What we did was drag this weapon script onto the weapon object, and I have this weapon script attached to this object, and thus our weapon becomes a weapon object. So think about it as we create a weapon object based on the weapon definition described in our script, in our class. And this is why our square is revolving around our green circle player representation. And this works because this is the logic that we have defined in our weapon class. So let's explore in more depth how our code actually works. In Visual Studio, find again our update method. We can delete this empty line with a semicolon at the end, and we have our transform line, which we have coded in the previous video. Now again, what is this transform part? In Unity, if you select our weapon and take a look at the inspector on the right, you will see that it has a transform component which has position, rotation, and scale. If I go now to the scene view and use the move tool on our square and try moving it up or down or left and right, you will see in the transform in the inspector that those values are changing. So the position, rotation, and scale are data of our object called transform. But we haven't created the transform script, so how do we have it? Well, Unity provides us with predefined scripts and we can access them because at the top of our script we have this using UnityEngine semicolon statement, and also some others related to the C# language itself. But actually, there is a bit more to it. In our script, just below those using statements, we have this public class weapon, and next we have a colon MonoBehaviour. And this part means that our weapon script inherits MonoBehaviour class, again provided by Unity. Now, inheritance is a topic for another video, but for now think about it as thanks to MonoBehaviour inheritance, we can access transform component on our object. So thanks to this colon MonoBehaviour, we can type transform in our script and it will know that this is the transform object attached to this game object in Unity. Now again, our class doesn't have any clue which object is it just yet. It will be any object to which we attach our script. Hence the need to reuse our methods because many objects might want to reuse the same logic defined in our class. So we know where we got this transform from, but now we are calling dot and rotate around, which is the method on this transform object. We can right click on this and we have this option to go to definition, and if we do, we are going to see the definition of this method. As the name suggests, we have this rotate around, so it will rotate an object around something. And you have those comments starting with the 2 forward slashes, so this is just a text rotates the transform about axis passing through point in world coordinates. You can also see that in between those parentheses, we are passing some values to this method. This is the data that this method needs to have to work correctly. In the comments you can see the parameters point, axis, and angle, so this is what we need to pass to this method. If we slide up in this script, you will see that there is this public class called transform defined here, and again, this class, like many others, is provided for us by Unity. Okay, let's go back to our weapon script, and here we have called transform.rotateAround. We use dot to access the methods and data of this transform object. Or in general, using dot allows us to access data and behaviors of any object defined in our script. Now to make our method run, we need those parentheses to call this method. And as you might recall, we need to pass some data to this method. So again, this is the center of rotation, this is the z-axis, so the axis of rotation, and this is the amount of rotation that we want to perform per each frame when our game runs. Now I will explain what data is and how we represent it in the next video. But again, the result is that the square weapon is rotating around our circle player representation. Okay, I know it was a lot and I don't expect you to understand everything just yet. In the next video, we are going to discuss what is this data in our C# script. See you in the next video.